Hello my dear students, again very welcome to all of you in your physics class, and we are talking about rotational motion. And in rotational motion the concept of moment of inertia is very important, as we are using mass in our translatory motion. In linear motion, same mass will replace by the moment of inertia in each formula for the rotational motion. All concept of moment of inertia are very important, and already we have covered all concept, all type of moment of inertia of all type of bodies, like moment of inertia of a ring, moment of inertia of a rod, moment of inertia of disc. We have covered moment of inertia of a spherical shell, moment of inertia of solid sphere. But what we have to do when we have to change the axis of rotation? So, to change the axis of rotation, we can use two theorem. First is parallel axis theorem and second is perpendicular axis theorem. So, in this lecture we will talk about parallel axis theorem. Whenever we talk about the moment of inertia, the axis of rotation is very important. Axis of rotation, we have idea about the axis of rotation, then only we can talk about the moment of inertia. The moment of inertia will change if we are changing the axis of rotation, because the mass distribution is changing with respect to different axis of rotation. So, the parallel axis theorem, what is the parallel axis theorem? Let us consider a body, and it is the center of mass of the body, and this is the axis is called centroidal axis. It is called centroidal axis. Centroidal axis, and the moment of inertia about this centroidal axis is Ig. What is Ig? It is the moment of inertia. Moment of inertia of body about centroidal axis, about centroidal axis, about centroidal axis. Now, if you want to find the moment of inertia about any parallel axis which is at distance h, from this centroidal axis, parallel axis, it is the parallel axis about which we have to find the moment of inertia. Now, let us consider it is x axis. So, the moment of inertia about x axis is equal to Ig plus mh square. M is the total mass of the body, h is the distance, parallel distance, this distance between these two parallel axes. So, it is the parallel axis theorem. What the parallel axis theorem? The moment of inertia about the parallel axis is equal to the summation of the moment of inertia, summation of moment of inertia about the centroidal axis and the product of mass and square of distance between these two axes. It is the parallel axis theorem, very important. Like, we can take some example. It is our circular ring, and in this case Ig is equal to mr square, you know very well. Now, what is the moment of inertia? What is the moment of inertia of this circular ring about any parallel axis like that, which is a distance r, which is passing through the rim and perpendicular to the plane of ring. So, this Ix, in this case h equal to r, Ix is equal to Ig plus mr square, Ig plus mr square. So, Ix, what is the Ig? It is mr square plus mr square. It will become 2mr square. It will become 2mr square. So it is very important concept. If you are changing axis of rotation, moment of inertia of any axis which is parallel to the centroidal axis is equal to Ig plus mh square. So how we can verify this parallel axis theorem? Okay, verification of parallel axis theorem. Verification of parallel axis theorem. So let us consider a rigid body, okay, and this is the centroidal axis. It is the center of mass. Now we are considering a mass m1 having distance r1, mass m2 having distance r2, same as it is mass mn having distance rn. What is Ig? What is Ig? Ig is equal to summation I equal to 1 to n mi ri square. Is this clear? It is a summation of moment of inertia of all body, all particles. Okay, if we are putting I equal to 1 m1 r1 square, if we are putting I equal to 2 m2 r2, so up to n we have to use the summation from I equal to 1 to n mi ri square. Okay, we have to put value of I from 1 to n and we have to add. It is the sign of summation. Okay. Now if we are taking, okay, let us consider a point mi which is a distance ri, okay, and this parallel distance is h, okay. So what is the moment of inertia about Ix, about this x axis of this mi? It is the mi xi square, or what is xi here? It is the ri plus h, okay. And if you want to moment of inertia of whole body, what we have to do? We have to do summation. So summation from I equal to 1 to n. So Ix equal to summation from I equal to 1 to n mi as it is, and xi is equal to ri plus h. The distance of this nth particle, this ith particle from this x axis is xi. It is h plus ri. This distance is h plus ri. So ri plus h whole square. Now what we can do? We can open this square. So we are getting summation I equal to 1 to n mi ri square plus h square plus 2 ri h, okay. Now we can multiply this summation and mi inside the bracket. We are getting Ix equal to summation I equal to 1 to n mi ri square plus summation I equal to 1 to n h square mi. Since this h is constant, not depending on I, so we can take common. So what we can write? We can write h square summation I equal to 1 to n of mi plus this 2h also common. So from I equal to n summation of mi ri, okay. This is the expression. Now what we can do? The summation of mi ri from I equal to 1 to n is equal to 0, because it is the moment of mass about the centroidal axis which is equal to 0, okay. If there is positive value of r, there should be negative value of equal length also. That is why it is equal to 0. What we can write? Why we are putting 0 of this summation mi ri? Because the moment of mass moment of mass about the centroidal axis, about the centroidal axis is equal to 0, is equal to 0. That's why we can put this term is equal to 0. And what is the meaning of summation of I equal to 1 to n of mi? It is the total mass. If we are adding mass of all particles, what we will get? Total mass of rigid body. So, and this term is equal to Ig. So, what we can write here? Ix equal to Ig plus mh square. This is the verification of parallel axis theorem. Ix equal to Ig plus mh square. Okay. Now, how we can apply this parallel axis theorem? To understand this concept, we will perform a numerical. Okay. So, let us see the numerical. For parallel axis theorem, in this question, we having 4 spherical balls having radius small r and mass m are placed at the corner of a square of side A, and we have to find the moment of inertia about any side first, then the moment of inertia about any diagonal. Okay. So, let us consider the side is there, this is the side. Okay. So, moment of inertia of this first particle, second particle, it is not particle, ball. First ball, second ball, third ball and fourth ball. So, I1 directly we can write 2 by 5 mr square. I4 also we can write 2 by 5 mr square. But what about I2? In this case, we have to use parallel axis theorem. Since the moment of inertia about the centroidal axis of I2, Ig plus m, what is the parallel axis, parallel distance, sorry, it is the A. This is the center of 2, and any axis which is passing through the center, the moment of inertia is 2 by 5 mr square. What we can write? 2 by 5 mr square plus mh square. So, it is m. And what is h? H in this case, we have to find the moment of inertia about this side. Okay, we can change the color. About this side. Okay, so it is the parallel distance A. So, mh square, h equal to A, so A square. Same as it is for I3, it is 2 by 5 mr square plus ma square. Okay. So, the total moment of inertia is I1 plus I2 plus I3 plus I4. So, I is equal to 4 times of 2 by 5 mr square, it is small r, sorry, it is a small r, plus 2 times ma square. So, I is equal to 8 by 5 mr square plus 2 ma square. This is the answer. It is the solution of A. Now, what is the moment of inertia about any diagonal? B. Solution of B part about any diagonal. Okay. So, these are 4 balls, I1, 1, 2, 3, 4, and let us consider a diagonal. This is the diagonal. Okay. So, moment of inertia of I1 is equal to 2 by 5 mr square, very simple, because this diagonal is axis which is passing to the center of the ball. So, it is 2 by 5 mr square, very easy. What is I3? Same as it is 2 by 5 mr square. But if we talk about I2 and I4, we have to find this perpendicular distance, this distance. So, what is the distance? It is the half of the diagonal, it is a root 2 by 2, it is h equal to a, we can write here h equal to a by root 2, a root 2 by 2, because the diagonal length of diagonal is a root 2 divided by 2. So, it will be a root 2. Now, I4 and I2 will be 2 by 5 mr square plus mh square. Okay. So, this I2 and I4 will be equal to 2 by 5 mr square plus ma by root 2 whole square. So, 2 by 5 mr square plus ma square by 2. Finally, what we have to do? We have to add all these I1, I3, I2, I4. So, we are getting the total I is equal to 4 times of 2 by 5 mr square plus 2 times of ma square by 2. This is the answer. Okay, this is the answer.